Assalamu alaikum wa rahmatullahi wa barakatuh. Brothers and sisters, Assalamu alaikum. Alhamdulillah, we're going to continue our discussion again tonight. We are actually approaching towards the moment of creation, which is the moment of the Big Bang itself. So we're going to try to understand it from the scientific point of view first, like the underlying principles and what actually happened before we proceed to dissect and discuss the Quranic verses and the hadith, the things of the Prophet ﷺ concerning about the moment of the creation or the creation itself, right? Now, we have covered on quantum mechanics last week. I'm not going to repeat that. I hope if you want to read further on quantum mechanics, you can easily find most of the, what they call it, materials and information on the internet, right? Choose the one that is easiest first to understand, be devoid of all equations, then you move on to something that is more difficult. You don't start from reading from the Wikipedia, because the article in Wikipedia is a little bit technical. I don't say little bit, very technical. You can start with other pages, internet pages that simplify quantum mechanics. In essence, quantum mechanics states that uh, the state of the subatomic particle depends on the observer, right? The, what do you call it, the subatomic particle can be in this position or in that position. We do not know until we observe it. Once we observe it, then the option whether this or that will be collapsed, disappear, and only one option left. And what is that option? That is the option that Allah SWT has determined, right, from Lahul Mahfuz. So everything is in a state of options. That's why it's called statistical mechanics. Quantum mechanics actually statistical mechanics. So it can be this or that. Statistically, it can be this, but it can also be that. Right? Once you observe it, then the statistics disappear, then you are pinpointing towards the same thing. Now, that is the essence of quantum mechanics. Another thing that arises from quantum mechanics is quantum fluctuation. Now, the word fluctuation itself conveys, right, what is it all about, the essence of quantum fluctuation. It means that things fluctuate. Things are not fixed. It can be this or that, right? It can be in a state of energy, or it can be a state of mass. Now, quantum fluctuation give rise to that famous Einstein equation, E is equals to mc squared. That equation, E is equals to mc squared, which is E is energy, equals to m is mass, and c is speed of light. This is the one, right? E is equals to mc squared. Now, it means that energy can be derived from mass. You have mass, you destroy the mass, then you can get energy. And the mass here is basically atomic mass, right? So you can just have a very, very tiny mass, but it can produce tremendous amount of energy. Why? Because this equation says that that mass that produce the energy must be equated with speed of light, and you square the speed of light. Now, this speed of light is the maximum speed in this universe. Allah SWT has said that is 300,000 kilometers per second, right? This is speed of light. Now, 300,000 squared, you get 27 followed by 12 zeros. 12 zeros, because 300,000, you have 5 zeros. So 27 followed by 10 zeros. That's a huge number. 27 followed by 10 zeros. And then this huge number, you multiply it by the mass that you have. If let's say I'm someone is 70, 80 plus kilogram, right? You multiply that by that huge number, 27 followed by 10 zeros, you have a huge amount of energy being produced by that mass. So that is why, right, nuclear explosion, atomic bomb, nuclear missile, nuclear bomb, all these things, they just need a tiny amount of mass, which is uranium. They put it as, let's say, 1 ton or 100 kilogram, 1,000 kilogram, right? And then after that, once you have that mass, then you heat it, then the mass somehow or other will be converted to energy. That's when you have tremendous amount of energy. And that's why atomic explosion or nuclear explosion is the biggest explosion ever. And that is why that is the secret of the power of our sun. Our sun, right, has been producing tremendous amount of energy, it's pouring, right, tremendous amount of energy at every second, and never stops for more than 4.6 to 4.7 billion years. The sun has been shining for 4.6 to 4.7 billion years, at least 4.5 billion years, and will continue to shine for another 4.5 to 4.6 billion years. Our sun is in its middle age, right? It's in the middle. How do we know that? That is a subject of astronomy where you can see the evolution of stars. So all of these 4.5 billion years, the sun has been pouring tremendous amount of energy. Where does this energy come from? This huge amount of energy comes from the conversion of mass to energy from the equation E equals to mc squared. Okay, so energy can be produced from mass. And if you look at the equation, all mathematical equations, right, it can go both ways. It can go this way, it can go that way. So if energy can be produced from mass, mass also can be produced from energy. You have tremendous amount of energy or any energy, then that energy can be converted to mass. Now, this is actually comes about from quantum fluctuations, where you look at the first two bullet points here: position versus momentum and energy versus matter. It means here, right, quantum fluctuation, which is also known as uncertainty principle, or usually been equated to the founder of this uncertainty principle, which is Heisenberg. So Heisenberg, we call it as Heisenberg's uncertainty principle. It basically says that because of quantum mechanics, right, or all of these statistics. Now, if you have a subatomic particle, okay, you want to find its position at any given time. If you know its position, you will never know its speed. If you have a car, let's say like this, right? You have a car. You look at this car, right? And then you have a police camera. The camera can capture the position of the car as well as the speed of the car, both at the same time. Both at the same time. Okay, that is why they can capture where there is a speed trap over there lah. But if you go to subatomic particles, if you want to capture the position of that particle, you can never find its velocity or its speed or its momentum. They use the scientific word as momentum. Right? You cannot find how fast it's going if you want to know its position. Now, if you want to know its velocity, then you will never find out where it is situated. You can find, okay, this electron is moving at so much speed, but where is it right now? I do not know, because in quantum world, in a very, very small world, you can only find one without the other. That is the limitation Allah put to us in our present knowledge. Imagine, that's why we cannot, you see, everything that we know is actually very, very limited. Even to find two parameters at the same time for subatomic particles is difficult. It's not difficult, sorry, it is impossible according to quantum theory. If you want to find the position of that thing, you cannot find its velocity. If you want to find its velocity of the particle, you cannot find its position. So if we use the analogy of a car, if the car is, let's say, is a subatomic particle, right, it's moving, and the police wants to capture the speed of the car and the position of the car, the policeman has to choose. Do you want to know the position of the car, or you want to know the speed of the car? If you want to know the position of the car, then the speed is blank. You can never know how fast it's going, because it's going to be stationary just like that. Now, if you want to find the speed of the car, you can never know where is that car actually. Right? It might be here, it might be there, it might be further up, it might be before that, because once you capture the speed, the position of the car is all statistics. So quantum mechanics means, right, the options, you have to choose which options. So it applies to position, and it applies to position versus speed. So if you, it is statistically like that. If you observe the speed, you can never observe the position. If you observe the position, you can never observe the speed. This applies only for very, very small particles, subatomic particles itself, right? If it is a huge thing like molecules, right, then you can measure both at the same time, right? If it is bigger than that, of course, right, you can measure both very accurately. Now, going back to the uncertainty principle, uncertainty means you don't know, you're not certain which one you can measure correctly. It depends on your choice. As an observer, which one you choose to observe, the other one is unknown to you. Now, it also goes to energy versus matter. That is basically E is equal to mc squared, right? So at a very, very small slice of time, in a very, very small slice of time, at 10 to the power of minus 44, 10 to the power of minus 43, right? Second, energy can be instantaneously converted to matter. And then that matter will collapse back to become energy. That is the essence of Einstein's equation, right? Energy, right, can be converted to matter because E is to mc squared. Of course, it needs tremendous amount of energy, right, to produce a matter. But then the matter will collapse back to become an energy, not energy, to become energy. So this space, if you look out there, right, our space is vacuum. We consider as vacuum, right? No air out there, right? In between stars, planets, right? In between us and the moon is empty space. Now, what we know about empty space is actually not empty at all. Even if you want to create vacuum on Earth, we suck the air, everything, all the air out, and we have a container that is basically without air, devoid of any particles of air. Let's say we are able to do that. We suck out all the molecules of air. So inside that flask, inside that container, is basically vacuum, right? Zero vacuum. Now, conventional science, conventional physics says that if you suck out all the molecules of the air, then that container will contain nothing. Nothing at all. Not even electron, not even proton, not even an atom. Nothing. So that is called as a pure vacuum. Now that is according to conventional science. But if you look at quantum mechanics, right, and the uncertainty principle, any space contains energy. Space has energy. Why do we know space has energy? Because everything comes from the Big Bang. And the Big Bang is pure energy. So the energy is permeating towards this universe. Everywhere there is energy. There is what they call it, a regular supply of energy. And you can't suck out the energy from a system. The energy should always be there. Now, because the energy, of course, the energy level is very, very low, right? But because there is an energy in that container, even though it is pure vacuum, no molecules at all, but space, it contains space, okay? Everything has space. So even is pure vacuum, there is space inside there. That's why we can calculate the volume of that container, right? Whether it's full of air or without any air, it's still space. So when there is a space, whenever there is space, there's always energy. Whenever there is space, there's always energy. And this energy is very, very low level energy. But because of quantum uncertainty, at a very, very slice of time, right, at a very nano microsecond, which we can't actually observe, right, but instruments can observe, of course. At that very, very very small slice of time, minuscule slice of time, that energy, because of the uncertainty between energy and matter, that energy can actually be converted to matter. Then suddenly, right, a particle form. You have sucked in all the particles, subatomic particles. Then suddenly, there's a particle form out there. Then you start to scratch your head, where this particle come from? Because I've sucked everything out. This particle comes from pure energy that is contained in space. Subhanallah. It's how Allah creates this universe, this physical universe, our physical universe, permeated with energy. So particles can appear out of energy, but at a very, very thin slice of time. Right? Now, please do not suddenly think that, oh, then there's a possibility that of course jinn is pure energy, so jinn can appear as a physical form. Not talking about jinns, right? Those are metaphysical creatures. They are not physical creatures. We are talking about physical things, and physical things includes our physical space, which includes energy. So this energy is actually inside our physical universe, right? The genes, they live in another realm, which we do not know, right? How is it? Another space-time dimension, right? That only Allah subhanahu wa ta'ala knows, but they share the same space or the same domain with us on Earth, right? There's no gene. Gene does not reside in planet Mars or Moon or Jupiter, whatever. It is on Earth itself. Okay. Now, at a very thin slice of time, suddenly particle appears. And what is that particle? It's a particle of light, photon, or it can be electron. But to produce electron needs a lot of energy, right? So because the energy level is very low, so the easiest mass to appear out of nothingness, to appear out of pure energy, very low level energy, the easiest particle to appear is photon, the particle of light. Now, photon, and this is the fact that current science has found out, right? What do you call it? Nuclear physics, right? Dictates it and has found out. But what actually Allah SWT has said it way before, when Allah SWT revealed the Quran to the Prophet SAW. Allah SWT says in two places in Al Quran, two different verses in Al Quran, that Allah created everything in pairs. So therefore, right, physicists, they say that the creation of particle out of energy, that particle must come in pairs. Why? Because everything is created in pairs. So the easiest particle to create is photon, which is the blue circle inside the screen, and it's anti-photon, which is the red thing. Now, it must be created in pairs because it must balance out. The photon carries a positive energy, the anti-photon carries the negative energy. You combine them together, it goes back to the same energy level, right? So there are this one energy produces two particles, and then these two particles separate itself, and then, right, it will merge itself back again. So at a very thin slice of time, energy, right, will appear or will give rise to a mass, or no, sorry, a pair of mass, which is two particles, and almost instantaneously after that, these two particles will collide each other back and disappear into a mass of energy. So sorry, not mass, sorry, sea of energy. So you have a sea of energy. Suddenly, two particles appear and it balances itself out, positive, negative. And then after it annihilates itself because it hit each other, so it annihilates it themselves, right? They will return back to the same level of energy. So this is basically what they call it, creation of matter from energy out of uncertainty principle, because you are uncertain. At a very thin slice of time, energy can become matter, matter can become energy. And this is basically what Stephen Hawking, right, in his very famous book, what they call it, A Brief History of Time, talks about evaporating black holes. Right? The concept of evaporating black holes is basically because of energy creates photon and antiphoton, but then the antiphoton or the photon is being absorbed into the black hole, and the antiphoton radiates out of the black hole. So basically, the what do you call it? The black hole lose mass or lose energy. So it's what do you call evaporating or disappearing. This is a very little bit deep lah. If you want to find out more, you can read that very famous book, A Brief History of Time, that contains only one equation, which is E squared mc squared. Because Stephen Hawking deliberately, right, when he wrote the book, and he did not write the book using his hand, mind you, he wrote the book using what do you call it? His fingers that move a cursor on every single letter. So you can imagine how tedious for him to write the book. But he just included just one equation because he said the more equation I put in, right, the less people were attracted to the book. But it is a very good book, lah, right? If you want to read it. He wrote it in, if not mistaken, in 1980s, right? Basically late 80s or early 90s, something like that. I think late 80s. It was, I mean, a bestseller. Very readable, right? I read the book, very nice, right? And I think if you read the book also, you can understand it, right? Because he explained it very well. So whatever it is, right? The uncertainty principle talks about energy and matter. The energy can convert to matter. Matter can go back to energy at a very thin slice of time. All right. Now, this is very important concept because this is actually what scientists say caused the Big Bang. What what caused the Big Bang? How can the Big Bang came about? Right? Some scientists they postulated or they theorized that because of this uncertainty principle, right, at a very, very thin slice of time, there was an energy, right? There was energy from another universe, a primordial universe, or another universe that were already in existence before our current universe. Imagine, right? This is just a theory because it can never be proven. So this energy, because of uncertainty principle, right, it became mass. But instead of that mass collapsing back to energy, that mass, right, grow or grew, past tense, right? That mass grew and expanded, and this is what we call as the Big Bang. And then it continued to expand and become another universe. So it becomes a baby universe out of the primordial or the original universe. So they say that our universe here, right now, right, was given birth by another universe. In other words, right, our universe came from another universe before it. And that universe might probably came from another universe before it ad infinitum. It means that it goes on forever and ever, right? There's no end to it. But because that is a theory, right? Not proved by anything, just mathematical theory. But it's very interesting thought because it comes from that uncertainty principle. So to them, Big Bang is actually the manifestation of uncertainty principle that talks about energy and matter at a very, very, what do you call it, small slice of time, right? The energy in that space was converted to matter, and that matter expanded into a space, another space. I mean, this universe give a previous universe gave birth to our universe and expand, and our universe becomes another big universe. So it's just like, you know, a balloon, and you put another balloon on top of that balloon. But these two universes will always be disconnected. Disconnected by what? Disconnected by that very, very small space where the baby universe, right, came about from the mother universe. Okay, that is basically what multiverse is all about, the multiple universe or several universe. I'm going to explore that again later on when we talk about the 7 layers of heavens, inshallah. Now, let's move on to Planck's time, right? Now, Max Planck, one of the German's physicists, okay, he discovered this phenomena that there is actually no time zero. There's nothing that can be considered as t is equals to zero. You can do it in your mathematics, right? Especially in mechanics. If you take mechanics, what do you call it, in your maths at A-level or physics at A-level, you have to study mechanics. Now, when you study mechanics, right, it is actually a very simple diagram. It's actually a very simple, what do you call it, a simplification of the real world. So it starts with t is equal to 0. See, so if this is stationary, then t is equal to 0. At t is equal to 10 seconds, what is the speed of the car? At t is equal to 12 seconds, what is the speed of that thing? If you have a fan, then the fan is stationary at t is equal to 0. But then the fan starts to rotate, right? At t is equals to 10 seconds, what is the speed of rotation, the angular momentum of that fan, at the blade of that fan? You have to calculate it. So they always start with t is equal to 0, but in actual fact, in this real world, there's no such thing as t is equal to 0, because time cannot reach into something that is 0. What is 0 actually? 0 is something that is not there. That is 0. When you say 0 thing means it's not there. So time is equal to 0 means time is not there. But that is impossible, right? So Max Planck discovered that as much as, you know, this universe has the maximum speed limit for everything, which is the speed of light, in this universe, right, there is the smallest time achievable that forms the limit of time. You cannot go smaller than that time itself. So time actually does not start, this whole universe does not start at t is equal to 0, but it starts at Planck's time. And what is Planck's time? It is 5.4 times 10 to the power of minus 44 seconds. If you can imagine, you just take 4 followed by 43 zeros after it. 43 zeros. How many trillions, billions, trillions, and trillions of a second? It means that 1 second, you divide it into that trillion and trillion and trillion slices of time. That's a very, very small slice of time. That is actually Planck's time. And that is actually, right, the time taken for light to travel the Planck's length. So we have a Planck's time, we have a Planck's length. Now, what is Planck's length? This is another limitation to this universe, the third limitation. Right? The first limitation is limitation to speed. Second is a limitation to time. There's no t is equal to 0. Allah subhanahu wa ta'ala does not allow us to calculate or to go lower than that limit of time, which is Planck's time. Another limitation of this universe is length. You can never go shorter than Planck's length. What is that Planck's length? It is 1.6 times 10 to the power of minus 33 centimeter. Or you can put it as 1.6 times 10 to the power of minus 34 millimeter. That's very, very small. 1.6, right? 1.6 followed by 33 zeros after that. Sorry, 0, 0, 0, 0, 33 zeros. 0.000000, you have 33 zeros after that point time. After that decimal point, you have 33, then 16. That is how short that length is, the limit of length in this universe that Allah has set. You can never go lower than that. You cannot go lower than that. It means you cannot go 1.5 to the 10 of 4 minus 33. So you cannot have 0.00000, you have 33 zeros, then followed 1.5, which is shorter than 1.6. Cannot, right? It is impossible. That is the limit. As much as there's a limit in time. 5.4 to the 5.4 times 10 to the power of minus 44, it means it's 0.000000. You have 44 zeros followed by 5.4. If it is 0.1 second, it's still okay, right? That's the speed that people measure for those who wants to run 100 meters, or 0.01. You can still achieve it by your stopwatch. But 0.00001 is impossible to use any device that we have right now. We have to use atomic clock to measure it. But 0.0000 with 44 zeros, then followed by 54 at the end, that's impossible. Nobody can measure it, right? That is the limit of time, and that is the limit of length, which is what the time taken for light to travel the Planck's length. And that Planck's length is actually 10 to the power of minus 20 times the distance across a proton. You imagine a proton, right? Proton is so small already, subatomic particle. Now, that Planck's length is 0.00000000 with 20 zeros, 1 of that length of, or the circumference or the diameter, not circumference, the diameter of that proton. So we have this proton. Let's say we enlarge a proton and the proton is like this, right? The Planck's length is 0.000000, 20 zeros, 1 of that length. So very, very tiny space. And if light travels across that then tiny space, the time taken for light to travel, that is the Planck's time. So that already gives you some idea on the very, very short period of time, right, for Planck's time, and a very, very short length for Planck's length. Cannot go lower than Planck, they cannot go shorter than Planck's length, and cannot go faster than Planck's length, Planck's time. Okay. Now, these two actually plays a role in determining the Big Bang, because Big Bang, right, does not start at t is equals to 0. It's impossible, right? But Big Bang starts at t time is equals to Planck's time, which is 0.000440 zeros followed by 54. That Big Bang starts from that time. And during that moment, right, of creation, the size of this universe, this huge universe, you compress it, really, really compress it to Planck's length, which is tinier, tinier, tinier than proton itself. And if proton, right, consists of quarks, Planck's length is tinier than quarks. Now, what is tinier than quarks? Quarks is made of what? There are some theories, like they call it string theory, but we're going to cover that later on, right? But nothing can go shorter than Planck's length. So this universe starts at Planck's length at Planck's time. The Big Bang, right, starts at Planck's length of its size, and the time is Planck's time. Does not start from t0 and not start from 0.0. No such thing as 0.0. Now, to give you a sense of how small that what do you call it, the measurement of Planck's length, and if you have a person here, right, which is usually about 1 meter if we sit down, so that is 10 to the power of 0, right? Let's say 10 to the power of 0, which is 1. Anything to the power of 0 is 1, right? Now, blood cell is at 10, between 10 to the power of minus 6 to 10 to the power of minus 3. That's very small already, but still, right, visible through our microscope. Then at 10 to the power of minus 12, just 10 to the power of minus 12 to 10 to the power of minus 9, that is the width of an atom, which nothing can be seen. We can only see atom, right, through atomic microscope. Not using light, but you're using electrons. We call it as electron microscope. So you can see some what you call it, a very blurry picture of an atom, and people have taken it, right? A very blurry picture of atom. Now, at 10 to the power of minus 15 meter, that is the what do you call it, the size of atomic nucleus. Of course, it depends on the atom itself, right? The bigger the atom is, the more nucleus it has, and the bigger will be the nucleus, right? But if you talk about the nucleus of hydrogen atom, then hydrogen atom consists only of 1 proton, right? So it is lower than that. It's at 10 to the power of minus 18. Now, this is the name given by, of course, scientists. meter, then after this is millimeter, then micrometer, then nanometer, then picometer, then femtometer is the size of what do you call it, atomic nucleus. Then below that, which is the size of the particles of nucleus itself, the proton, the neutron, will be attometer. And zeptometer, which is 10 to the minus 21 meter, that's the size of, might be electron. And then below that will be yoctometer, 10 to the 24. Then after that, no more name. Run out of name because it's too short, doesn't make sense at all. And right to the end here, 10 to the power minus 34 is the Planck's scale, which is the Planck's length. Right? You cannot go below the Planck's length. So there is nothing as zero length in this universe. Right? So everything starts with Planck's length. Right? So this makes some what do you call it, sense, right? How small it is. You see, from size of a person to the size of atomic nucleus, it just takes to the power of 15, right? Logarithmic scale from 0 to 15. But Planck's scale is 33. So from atom, if you blow up atom to the size of a human being, right? If you blow up a nucleus of the atom the size of a human being, then Planck's length is at the size of the atom itself. So the relationship between atom to Planck's length is the same as the relationship between us and the atom or the nucleus itself. So that's how far stretch it is. So from us to Planck's length is double that stretch of length, the scale, length scale. So beyond actually our wildest imagination. That's why science is said something that is very, that's stranger than what people can imagine actually. Now, the moment of creation that I shared with you, right, when time is equal to Planck's length, 10 to the minus 44, so the universe starts at this time, Planck's time, and at that time, the universe size is as Planck's length, not zero. So there's always some space there. Now, if you look it from the perspective of our aqidah, our belief, Islamic belief, right? Then it's very logical. It is very logical, and it actually synchronize and tally with our Islamic belief. Our Islamic belief dictates and says that everything occupies space. The only one that does not occupy space is Allah subhanahu wa ta'ala. And Allah, because Allah by virtue, Allah creates everything, Allah creates space and time. So therefore, space or length, right, cannot be attributed to Allah. If you have a length that is zero, then that's basically Allah's domain. Because Allah does not occupy space. So when we talk about Allah, then length is equals to zero. When we talk about creatures, then length cannot be zero. Length can be anything but zero. So that is why this universe, right, cannot start from length is equals to zero or at a point of zero point. Then after that, it expands to Big Bang. Because if you talk about 0 point, then that is Allah itself. Then that is impossible, right? Because we are talking about physical things. We're not talking about the Creator, Allah subhanahu wa ta'ala. So Allah subhanahu wa ta'ala does not occupy space. So L length is equals to zero if you want to talk about Allah subhanahu wa ta'ala. Because what is zero? Zero is basically nothing. Zero is not a number, right? Zero is a symbol. A symbol for what? A symbol for nothingness. Zero, nothing, right? And that is why the Arabs, they never found zero. They always starts from one. And also other civilizations, right? They never found zeros. It's actually 1 or then -1 lah before that. But 0, no. That's why there's no year 0. Year starts from year 1, right? The concept of 0 only came to the Arabs from the Indians, the Hindus, because in Hindu philosophy, right, in Hindu religion, there's something that is called as nothingness, and that nothingness, nirvana, right? They call it as nirvana, nothingness. That is a breakup from the vicious cycle of reincarnation. They believe that soul will always be reincarnated to another physical being, right? So you can only break this cycle of reincarnation if at every stage of reincarnation you do good deeds, right? So you better your soul, so you will go up the level of creatures. That is why in Hinduism they have this, what they call it as the caste, what they call it, concept. So you got the caste level into Brahma level. Then if you do good some more, then after that your soul will break free from that cycle of reincarnation and you will go to nirvana. What is nirvana? Nirvana. Nirvana is nothingness. It's pure bliss for them. Right? You don't have to go back to this life on earth. So that nothingness, they put it as 0, right? And then, yeah, it's a concept. So then the Arabs took it, and then they said it is sifir. Sifir means empty. Of course, the Arabs also have the concept of empty. That's why the month of Safar, right? Safar, Muharram, Safar. Safar means empty. Why is it empty? Because the Arabs, after they set out for 3 months without fighting among each other, when Safar comes, right, they will go out and fight. So the villages, the encampments, and all those towns will be empty of people, devoid of males who went out to fight. So they call it Safar. So Safar is emptiness lah. So when they took the concept of 0, which is part of a number system in Hindu belief system, they put it as sifir. So, sifir, wahid, ithnan, thalatha, arba, khamsa. So 0 is nothingness. So when we said Allah does not occupy space, then length is equals to 0 for Allah, because length is not applicable to Allah. Other than Allah subhanahu wa ta'ala, all creatures occupy space, whether it's a physical space or metaphysical space, right? The same goes with time. The same goes with time. Now, Allah creates time. Allah is not subjected to time, right? Time is the creation of Allah. So Allah is beyond time. Allah transcends time. So if we say t is equals to 0, means that there is no time, then we are talking about Allah. Because Allah is timeless. No time attributed to Allah subhanahu wa ta'ala. We talked about this thing before. The Prophet ﷺ said, Allah kan Allah wa lam yakun ma'ahu shay. Allah existed in a timeless situation, right? And nothing exists beside Allah subhanahu wa ta'ala. So Allah exists, there's no time. So when you say t is 0, when there's no time, it refers to Allah. Whereas all creatures, we exist in time, right? In a time, what do you call it, scale or time length or time arrow, whatever you want to call it. So we exist in space and time. That's why we have space and time. So time cannot be 0 for us. And that is discovered by Max Planck, right? There's no such thing as t is equals to 0. Yes, you can use it for calculations. Yes, play around, right, with some equations to some questions for academic purpose of thinking and exercise, and that's all. Right? But in reality, there's no t is to 0. If you say that this thing is t is equals to 0, there's a high chance that you're going to commit shirk. If you say that this thing is length is to 0, right? Volume is equal to 0, then there's a high chance that you're going to commit shirk. Why? Because only Allah, right? Only Allah has the privilege of t is equals to 0 and L, which is length, is equals to 0. Other than Allah subhanahu wa ta'ala, t is equals to something and L is equal to something. So the moment of creation for this universe, right, it starts with t is equals to 10 to the power of minus 44 second, which is 0.0000044 zeros second, right? 0.00001 second, and the size is 0.0003501 meter. That's how small it is. Okay, now we move on to the temperature of the universe. I'm going to cover a little bit more about this next week because we're going to talk about these four fundamental forces of this universe. And I drew this straight line, which is very important. This is the line that what they call it, the standard model of Big Bang ends. Anything that goes beyond this line, right, on the right side of this line, right, those events have been agreed upon by majority, almost all scientists, physicists, astronomers. But anything that is on the left side of this line, this red line, is not being agreed upon by all astronomers. So this part is actually the disputed part, right, by the scientists. This part, where you have all these colors, right, these four forces, this part has been agreed upon by almost all scientists. So what is this line, right? 10 to the power minus 10. We're going to talk about this thing, inshallah, next week. Okay, so we're going to almost finish discussing about the Big Bang, right? And after we finish discussing all the scientific parts, scientific aspects of Big Bang, we're going to move on to the discussion on the Islamic sources that talks about the moment of creation itself. So we have to understand the concept, right? First, from the scientific point of view, then we can appreciate, right, discussion on all those hadiths and Quranic verses, inshallah. So that will be, I predict, 2 more weeks, inshallah, hopefully. Wallahu a'lam bissawab. Okay, so let's see if there's any question. All right, there's a question here. Do you think multiverse theory makes is rational because it has the concept of infinite regress. Going back infinitely means we won't be in this moment right now, right? Yeah. See, multiverse, like I said just now, right? Ad infinitum, it means that universe being born from other universe, right? And continuously ad infinitum never ends, right? So when we talk about infinity, then infinity belongs solely to the domain of Allah. Beyond that, right, creatures are all finite. But when we talk about, let's say they say, oh, then after that, if we die, we go to heaven, then there's no end to that. Yeah, right? There's no end to time if we go to heaven or paradise, inshallah, min ya rabbal alamin. As much as there's no end for time for those who reside in hell, those kuffar, those unbelievers who die as mushrikins. So they will be punished forever and ever. So that's infinity also, right? But infinity in just one aspect, that is going forward, not going backwards. We always have a beginning, right? So we have a beginning, but we do not have any end. Whereas Allah SWT has no beginning and has no end. And our endless state, forever and ever, right? That is because of Allah's, what they call it, permission for us to exist in that state. But we must have a beginning. So I'm telling all of us right now, right? You are, or we are all facing an infinite time in front of us. People think that no, I'm going to die. Yeah, yes, but dying, death is just a stage where you move on to another world, which is the barzakh world, and there we will continue to live. Whether we'll get all the favors from Allah subhanahu wa ta'ala or the ni'mah, or people will be punished in the barzakh world. Then after that, there will be the end of time, Yawm al-Qiyamah. Then we'll be resurrected. We'll be facing endless time again. Standing there, we do not know how long we're going to stand, waiting for a judgment. Then the judgment comes, whether we're going to paradise or hell. Amin ya Rabbal Alamin, we go to paradise. And then there'll be endless pleasure. There'll be endless time to enjoy in paradise. right? So we are facing endless time, right? So infinity towards the front, but not infinity to the back of time. So because we are trapped in time, even though we're going to be in paradise, but we're going to be trapped in a different stage of time, different state of time. Our current state of time will end at Yawm al-Qiyamah, and then we will live in a different state of time, a different concept of time, which beyond our imagination, how it's going to be like. Okay, but again, right, multiverse talks about multiple universe. In Islam, we have 7 heavens. 7 heavens. So how do we marry this concept of 7 heavens to this, what do you call it, multiverse? That I will discuss later on, inshallah. We're going to dissect and discuss all those verses from the Quran and the Hadith, inshallah. Future lectures. So stay tuned, same channel, same time next week, and until Allah decrees otherwise. All right, so thank you very much. We stop here with Tasbih Kafara and Surah Al-Asr. Subhanaka wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawassaw bil haqqi wa tawassaw bis sabr. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.